We now need to look at a process called completing the square. You'll notice that all of our problems where we were using square root property conveniently worked out to having just the type of square we needed, that we could isolate and then apply the square root property to. Notice that that's not always going to happen. We're going to look at a problem where that doesn't happen. So when we're trying to solve this type of equation, ax squared plus bx plus c equals 0, where a is not 0, by completing the square, we will divide both sides by a if a is not 1. Then we'll move our constants to the right side of the equation. Then we'll find half times the coefficient of the x term, square it, and add that on to both sides of the equation. Then the left-hand side will now be a perfect square, and we'll rewrite it as a binomial squared. Then we'll be all set to use the square root property to solve for x. So let's look at an example of this. Let's look at solving a quadratic equation by completing the square. Now notice here we're not able to use the square root property right off the bat, because we don't just have an x squared term, but we also have an x term. So when we go and move our constant to the other side of the equation, we don't have simply a perfect square left on the left side, but we've got a perfect square and then an x term. So that is in the way. That x term is keeping us from having something where we can apply the square root property, because previously when we applied the square root property, the only thing on this other side once we move the constant was a perfect square. But what we're going to do is we're going to make this a perfect square. So we are going to add on a perfect square. And if we do that to the left side of the equation, we also have to do it to the right side of the equation. And what I do is I merely look at the number that's here in front, or the coefficient of x. I can ignore the negative if it's negative, and simply look at the number being multiplied by x, ignoring its sign. Since I'm squaring, what I'm adding on is always going to be positive. So I'm going to take the 16, the coefficient of x, which really is a negative 16, but I'm going to just take the 16 divided by 2, square it, and that's what gets added on to both sides of the equation. So the left side is x squared minus 16x plus the square of 8. The right side is now 9 plus the square of 8. Now, when I do this, what I've done is made the left side a perfect square trinomial. So that is going to factor into the square of a binomial. Whatever sign is in front of the middle term will be the sign in the binomial. And this simply factors into the square of x minus 8. And if you don't believe that, you can actually use the distributive property twice to see that x minus 8 times x minus 8 will give you x squared minus 16x plus the square of 8. Now on the right, I have 9 plus 64. So the left is the square of x minus 8. The right is 73. Now I'm ready to use the square root property. So I can lose this exponent of 2 on the left if I apply plus or minus square root to what's on the right. So now on the right I'll simply have x minus 8 and on the right I have plus or minus square root of 73. And I can add an 8 to both sides to isolate the x. And I now have x equals 8 plus or minus the square root of 73. And so I now am ready to write my solution set. So the solution set is 8 minus square root of 73, so the set containing 8 minus the square root of 73, or 8 plus the square root of 73. And that is how I solve a quadratic equation by completing the square.